Welcome back students, Standard 9th, Chapter 5, Introduction to Euclid's Geometry, and we are into the 5th session. Alright, in previous session, we learned about theorem, the different types of its proof, that is direct method, indirect method, and the method of induction. Alright, but forget about the third method, okay, because when we see them, we will have its discussion. Alright, then we saw how many lines can pass through 1 point, 2 points, 3 points. Now, 1 point is unique, one and only one. But when 2 points are there, they can be equal or distinct. When 3 points are there, they can be equal or distinct. And if they are distinct, they can be on the same line or can be on different line. So we have lot of divisions, classifications further. I gave you homework for 4 points. Find out the number of lines that will pass through 4 points and 5 points. And I promised also that we will start with that work. So let's see. 4 points. Now there can be 2 types of 4 points. Equal points and distinct points. All 4 points can be equal or distinct. And if it is distinct, children, very interesting, collinear. All 4 points on same line, alright. 3 points on same line, 3 points on same line. And third, I'll explain to you this. No 3 points are collinear or on the same line. Collinear means on the same line. Instead of saying same line, I can say collinear. All 4 points are collinear, 3 points are collinear, and no 3 points are collinear. Please try to understand. I'm using 4 color pens to represent 4 points. First case, equal. This point is A. Red pen. Same point is B. Black point. Same point is C. Which point is left now? Blue. And same point is D. So here A equal to B equal to D. So these are equal points. All 4 points are equal. That means they are coinciding. All 4 points are coinciding. Anything that coincides, they are equal. So here 4 points coincide. So they are equal. How many lines will pass through them? Yes, 1, 2, 3, 4. Infinite lines will pass. So here, when 4 points are equal, you will have infinite lines passing through those 4 equal points. Got it, children? All right. So that was about equal points. Now, if the points are distinct, those 4 distinct points can be in 3 different forms. First, all 4 points are on the same line. This is line L. A, B, C, D. So all 4 points, they are on the same line. Okay? This is one situation. And you see all 4 points are distinct. Points are distinct. And all 4 are on the same line. Now tell me how many lines will pass through them? Line L is already passing. If you try to pass another line through A, B, C and D, it's going to be again L only. Wahi line hogi. So here the answer is 1 and only 1 line passes. In other words, unique. So if 4 points are collinear, if all 4 points are on the same line, if they are distinct and on the same line, alright, then 1 and only 1 line will pass through it. I hope you got it. Child. Now, out of 4 means all four are not on the same line. Out of four, any three are on the same line. So let's say this is A, this is B, and this one is C. Only three are on the same line. The fourth point D, you can see all 4 points are distinct, A, B, C, D. But not all 4 points are on the same line. Only three are on the same line. Any three. Here A, B, C. Chaliye. This line, to draw the line we need only 2 points. So if I choose A and C, line L1 passes through it. If I choose A and D, line L2 passes through it. If I choose B and D, new line L3 passes through it. If I choose C and D, another line L4 passes through it. If I choose B and C, same line L1 passes. If I choose A and B, same line L1 passes. Correct? So in all, how many lines will pass if 3 points are collinear? Only 3 points are collinear out of 4. So 4 lines passes through 4 distinct points in which 3 points are collinear. One and only one line pass through 4 distinct points which are all on the same line. 4 lines will pass through 4 distinct points, out of which 3 are collinear. Are you getting me? Now, how many lines will pass through 4 distinct points in which no 3 points are collinear? Let's see. I'll draw those 4 distinct points in such a way that no 3 points are on the same line. Say this. Point A, point B, point C, and point D. Try. No 3 are collinear. कोई भी 3 collinear नहीं है. चलिए. I'll choose A and B. Which line passes? Line L1. Because to draw the line, you need 2 distinct points. I'll choose A and C. There is another line. Let me call this is line L2. I'll choose A and D. Let me finish with A. This is line L3. A and B, line L1. A and C, line L2. A and D, line L3. Okay. Now let me start with B. B and A, that is already L1. Now B and C, passing through B and C, that is L4. Then B and D, from B and D, alright, that is line L5. Correct? So B passes through A, line through B passes through A, line through B passes through C, and line through B also passes through D. Now D is left. Line through D already passes through B, line through D already passes through A. So now one is left, line through D passes through C, and this is L6. Bas, 6 lines will pass here. 6 lines will pass through 4 distinct points, out of which no 3 are collinear. Please children, be very careful. How many lines will pass through 4 points? If 4 points are equal, infinite lines will pass. If 4 points are distinct and collinear, one and only one line will pass. If 4 points are distinct and out of which 3 are collinear, 4 lines will pass. If 4 points are distinct and out of which no 3 are collinear, then 6 lines will pass. Are you getting me? So how many lines will pass through 4 points? 4 points. 4 points. 4 points means this. Either infinite or 1 line or 4 lines or 6 lines. So you have to see each situation nicely. Now what I am asking, how many lines will pass through 4 distinct points in which no 3 points are collinear? 4 points, distinct points, no 3 are collinear. 6 lines will pass. How many lines will pass through 4 distinct collinear points? 4 distinct collinear. So one and only one line will pass. How many lines will pass through 4 distinct points, out of which 3 are collinear, only 3 are collinear? Then 4 lines will pass. I hope you have understood. Now let's see 5. Let's see 5. I think you should try. You should try. Okay? Cha. Anyway, because I have promised you, I'll do it. Children, multiple choice question can be asked. Okay? I'll try to give you assignment today evening of all the videos that you have seen of this chapter. Alright? Fine. If not today evening, tomorrow definitely you will get. And tomorrow will be the last session of this chapter. We will be concluding the chapter as well. Chapter 5 will get over in the next session. Now 5 points. 5 points. As we know, all those 5 points can be equal, or you can say coinciding, or they can be distinct. Now we have 5 points. So distinct points में classification आएगा. All 5 are collinear. All 5 are collinear. Correct? Next classification में only 4 are collinear. Only 4 out of 5 are collinear. 4 points. Let me write 5 points are collinear. आगे क्या आएगा? Only 3 are collinear. Only 3 are collinear. Alright? और इसमें no 3 are collinear. क्योंकि collinear points 3 तो चाहिए कम से कम. 2 points are always collinear. So 2 points का आगे नहीं आएगा. Alright? So no 3 points are collinear. Alright? Let's start. This you can say very easily. All 5 points are equal. Point 1 A. Point 2 that is B. Point C on it. Point D on it. Point E on it. All 5 points are equal. So how many lines will pass? Infinite. So if 5 points are equal or coinciding, then infinite lines will pass through all those 5 points. Correct? Now let's see. This is also very simple. All 5 points are collinear. This is line L. Point A is here, point B is here, let's say point C is here, point D is here, point E is here. All 5 points are on the same line. 5 points are collinear. So how many lines can be drawn through them? Try to draw through A and B, L only. A and C, L only. A and D, वही line. A और E से वही line. B और C से वही line. B और D से वही line. B और E से वही line. C और D से same line. C and E same line. So it's one line only. So unique line passes through 5 distinct collinear points. 5 distinct collinear points. Then one and only one line will pass through them. Is it interesting? Fine. Can you follow? Alright. Now we are going to see only 4 points are collinear. So on the same line, I am going to draw or plot 4 points. A, B, C, D. Alright. And the 5th point is not on the same line. Yes. Now, start with A. A और B से ये line L1. A और C से वही line. A और D से same line. Okay. और A और E से नई line मिलेगी. This is L2. Now start with B. B और A से वही line. B, C same line. B, D same line. But you will get line from B and E. This is line L3. Now start with C. CB, same line. CA, CD, it's one and the same line. So line through C and E. This is line number 4, L4. उसी तरह D और E से you will get line number 5. Correct? Is any left now? Can you get any more lines? No. So how many lines you get if 4 points are 4 points are collinear out of 5? You will get 5 lines passing through 5 distinct points out of which 4 are collinear. Chaliye. Now let's see 5 distinct points out of which only 3 are collinear. Only 3 are collinear. Now this is interesting. यहां से भी 2 सब पार्ट आते हैं. We'll see that. Okay. See this. I'm drawing one. 3 points A, B, C are collinear. 2 points are left, right? Here, same situation. A, B, C. So 5 distinct points, out of which only 3 are only 3 are collinear. Only 3 are collinear. So you will not have 2 paths. Anyway. Okay, fine. Now see, please. 2 points are left, D and E. Well, where will you put? I'm putting one here, another here. Correct? Or I can put one here and somewhere here. So how many lines will pass? A or B say L1. A or C say L1. This is D and this one is E, the other point. A or B say L1. A or C say L1. A or D say L2. A or E say L3. Alright, now start with B. B or D say L4. B or E say L5. C or D say L6. Or C or E say L7. So how many lines will pass? If only 3 points are collinear, 7 lines. 7 lines will pass. Now in this situation, what sir is doing? Say place E and D. A, B, C, D and E. Yeah, only 3. अब ऐसे देखो तो भी 3 ही है. ऐसे देखो तो भी 3 ही है. Only 3 lines. Sorry, 3 points are collinear. So 5 distinct points in which only 3 points are collinear. But here you have one pair of collinear points. Here you have ABC one pair and then BDE other pair. Okay, let's see how many lines pass through. We start with A. A or B say L1. A or C say L1. A or D say नई लाइन मिलती है. So L2. All right. A और E से नई लाइन मिल रही है. So that is L3. Now B से start करो. B और C से तो same. B और D से नई लाइन मिल रही है, उसको L4 बोलते हैं. Correct? Anything else? B और E से वही लाइन. अब C से start करो. C और B, C और A से तो मिल गया. C और D से L5 और C और E से you got L6. Now you cannot get any more lines. So how many lines you are getting here? 6 lines. Be careful. यहाँ I'll say triplet. ये A, B और C उसको मैं triplet points बोलूँगा. Triplets. Alright? So in this situation we have only one triplet of points. One triplet of collinear points. Here 2 triplets of collinear points you have. A, B, C or B, D, E. Alright? In this case, 5 distinct points in which only 3 points are collinear, not more than that. Here A, B and C, 3 points. Here A, B and C, only 3 points. If you count this way, B, D and E, it is also only one triplet of collinear points. Okay. यहाँ एक ट्रिपलेट है, यहाँ 2 ट्रिपलेट है. 5 distinct. How many lines pass through? 5 distinct points in which only 3 points are collinear and there is only one triplet of collinear points. Then 7 lines will pass. 5 distinct points in which only 3 points are collinear, but we have 2 triplets of collinear points. Then how many lines will pass? 6. Alright, chalo. Now, the last, and that is, no 3 points are collinear. Out of 5 points, कोई भी 3 point collinear नहीं है. Alright, then how many lines will pass through that? Yeah, you can take the points like this. A, B, C, D और E. हो गए. कोई भी 3 point collinear नहीं है. Start with A. A और B से लाइन जाने दो, L1. A और C से लाइन जाने दो, L2. Let the line move pass from A and D, L3. Let the line pass from again A and E. This is L4. All the lines that could pass through A. And one more point from the remaining. We got it. Now let's start with B. You have already line passing through A, that is L1. Now B and E. This is L5. Now B and D. This is L6, line number 6. B and C. This is line number 7. Alright. Now we have to start with C. C और B से जा रही है लाइन. C और A से जा रही है लाइन. करेक्ट? एक मिस्ड आउट किया? नहीं. ओके, C से. C और B से जा रही है, C और A से जा रही है. लेकिन C और E से नहीं है अभी तक. लाइन 7 था लास्ट. नाउ दिस इज लाइन 8. और C और D से. This is line number 9. Got it? Alright. Now let's see. Lines passing through D. D और C से जा रहा है, D और B से जा रहा है, D और A से जा रहा है, लेकिन D और E से एक भी लाइन नहीं है. This is line number 10. बस आप देख लो पॉइंट A बाकी के 5 पॉइंट से जा रही है, पॉइंट B बाकी के 5 पॉइंट से जा रही है, बाकी के 4 पॉइंट. सॉरी यार. You can see A 1, 2, 3, 4 lines passing through A. B 1, 2, 3, 4 lines passing through B. C 1, 2, 3, 4 lines passing through C. D 1, 2, 3, 4 lines. Okay, it has to pass through remaining 4 points. E 1, 2, 3, 4. So totally how many lines we got? 10 lines. How many lines we got? 10 lines. So I don't think you must have got that. That's why I had promised you. I knew I will have to do it for you. Alright, anyway, you can try for 6 points. You can try for 6 points. Okay? Alright? Fine. Alright, children. Let's move further then. Children, if 2 points are given, A and B, they are 2 distinct points. Yeah, there exists one and only one line passing through 2 distinct points. P is point and Q is point here. So P and Q, one and only one line will pass. A is here and C is here. If you are talking about only A and C, then again one and only one line will pass through 2 distinct points. That's why we say 2 points are always collinear. 3 points A, B, C. ये collinear दिखते हैं, लेकिन A, B, C ये collinear नहीं दिखेंगे. लेकिन 2 पॉइंट A और A this 2 points एक ही लाइन, this 2 points एक ही लाइन, ये पॉइंट और ये पॉइंट एक ही लाइन. So 2 points are always collinear. Alright. So if you have 2 distinct points, then one and only one line can pass through it. And that is the statement of Axiom 5.1. Given 2 distinct points, for a given 2 distinct points, a unique line passes through them. Let's see the statement. Given 2 distinct points, you have 2 distinct points. There is a unique line. If it is 2 distinct points, unique line passes through them. So, given 2 distinct points, there is a unique line passing through them. This is axiom number 5.1. Alright. So I hope you understood that. Now in the textbook we have example 1, illustration 1. Let's see it. Okay. Then let's see. If A, B, C are A, B, C are 3 points on a line. Well, the points A, B and C, these points are 3 points on a line. That means those points are on a line. Let me say this line is L. Here is point A, here is point B, and here is point C. Oh, I have drawn it. B lies between A and C. I have done that. B is between A and C. See figure below. Okay. Prove that AB plus BC is equal to AC. You have to prove this. AB, the green part, plus BC, the black part, is equal to AC, the blue part. Alright? On line I am taking only the distance, the length of line segment AC. So green plus black is equal to blue. This is what you are supposed to prove. Children, recall Axiom 4, Euclid's Axiom 4. If two things coincide, they are equal. If two things coincide, they are equal. We have also learned betweenness. B is between A and C. So AB plus BC is equal to AC. But that we have to prove. How? Chaliye, just take AB, that is green part. Take BC, that is black part. If you combine them, then this combined part, green and black, exactly coincide with blue part, that is AC. So you can say AB plus BC coincides with AC. AB plus BC and AC, they coincide. That means they are equal. So AB plus BC equal to AC. Here we use Euclid's axiom number 4. Is that clear? Now how to write? Children, I have to write like this. Data means what is given. A, B, C are 3 points on a line such that you may write like this: A dash, B dash, C. You can use symbols. Children, you have to copy this in your book or notebook, please. And take a screenshot and write, or you may pause and write. Chal. To prove B lies between A and C. यहाँ आ गया, symbolically we have written. Now to prove, आपको ये prove करना है. AB plus BC is equal to AC. Correct? Proof. Children, theorem का proof. I have to use this. Alright? A, B, C are 3 points on a line. Alright? Such that A dash, B dash, C. How did you get this? ये कहाँ से मिला आपको? Data से. So you can say by data. Alright. Now what you have? Therefore, AB plus BC and the blue side AC coincide with each other. So they are coinciding. Therefore, AB plus BC and AC are equal because they are coinciding. Therefore, I am writing it here. Therefore, AB plus BC symbolically equal to AC. Alright. Why AB plus BC and AC are equal? Because they are coinciding. And who said that when two things coincide, they are equal? Euclid. By Euclid's axiom 4. Is that clear to you? And this is proved. AB plus BC is equal to AC. Hope you will be able to copy it nicely. Now we'll see the example number 2. Okay. So what is example number 2 now? Prove that equilateral triangle can be constructed on any given line segment. Prove that equilateral triangle can be constructed on any given line segment. You are given any line segment. Solution. Okay, data. I'll write data here. Alright. What is data? Yeah. AB is given. You are given one line segment AB. To prove equilateral triangle ABC. तीसरा पॉइंट चाहिए ना, so we can say ABC. ये हमें लिखना पड़ेगा. Equilateral triangle ABC can be constructed on AB. Equilateral triangle can be constructed on AB. All right. Proof. Let's see the proof now. All right, I'll do that work. So I have removed that part so that I can draw the figure there. What is given, children? Line segment AB is given. So I am drawing that line segment here. Here is line segment AB which is given. Correct? Now you have to show that equilateral triangle ABC can be constructed. You can get point C here such that AB equal to BC equal to AC. Children, we are going to use Euclid's postulate number 3, which states that you can draw or construct a circle with any center and any radius. So what I am doing it here? What I am going to do here, children? All right. See, I'll take center A. Any point can be chosen as center. So I am taking A as center. All right. Here it is. Here I have chosen A as center. And radius AB. How much is the radius? AB. Dekho. Here. I'm not drawing the whole circle. Now this part is gone. A is here. Alright. So I have drawn a circle with center A and radius AB. I have not drawn whole circle. I have drawn one out. Now I am going to draw a circle with center B. I'll change the center. I can take any center. Yes, center I am taking or choosing B. Very difficult to work with this because it sticks. Well, the point was here. Here it was. B was here. In this line. Okay, I'll draw it again. Yeah. Okay. Fine. Now I am going to draw a circle with center B and radius again AB. See this? And they intersect each other. Are you getting me? They are intersecting at this point C. Children, this center I took and this is the first circle I draw. So what is this? The radius. Correct? Center A and radius AB. So this is equal to AB only. AC equal to AB only. Now I draw a circle with center B and same radius AB. So this is the circle and this is the center. Point C is on the circle. So if you draw this is radius of the second circle. That is also equal to AB. So here you can say AB equal to AC because what that is taken that same distance and AB is also equal to AC. Please. AB is given. First step, ODI. Construct a circle with center A and radius. How much is radius? AB. Alright. Then what we did? Construct. Next step was construct a circle with center B and radius AB. Again the radius was chosen AB. Which ये दूसरा वाला सर्कल पहले वाले सर्कल को मिल रहा है. Which intersects first circle. This is symbol of circle. First circle in point C. Therefore, AB equal to BC. Therefore, AB equal to BC equal to AC. ये भी radius, ये भी radius, ये भी radius. That is equal to radius. Correct? Therefore, triangle ABC is thus, therefore, equilateral. Triangle ABC is thus constructed on AB. That's it. Done. Understood, children? Alright, fine. Alright, children, I told you you don't have theorem to prove. And yes, that statement is there. The proof is not important. But I want you to see, children, I want you to see how it is proved. And most of the things I have proved here, that is not essential for you people in standard 9 right now in this chapter. But I am doing it right now because in the advancing chapters, further chapters, you will need this. This practice will prove very useful to you. Okay, so we are going to see theorem 5.1. Just now we saw axiom 5.1. Now it is theorem 5.1. So theorem has to be proved by using logical arguments. Correct? Okay. Before we read the statement of theorem 5.1, we need to know what are distinct lines. Distinct lines किसे कहते हैं? Yes, here the two lines are not intersecting each other at all. L or M, they are distinct. Line P or T, they are distinct. Here they are intersecting. Here they are not intersecting. Here, L1 and L2, they are intersecting in one point. They are distinct lines. P1 and P2, they are intersecting. They are distinct lines. Line X and line Y, small letters represent line. They are never intersecting each other, but they are distinct. Distinct lines, distinct lines, distinct lines, distinct lines, distinct lines. All 5 pairs of lines given are distinct lines. What you noted? If 2 distinct lines are given, either they will be parallel, they will not intersect each other, or they will intersect. And what do you see? If they intersect each other, then they will intersect in one and only one point. एक ही point में intersect होगा. Extend this further. Produce this line further. Produce this line further. Both the sides, they will never intersect. So if 2 distinct lines intersect each other, then they will intersect in one point. If 2 distinct lines are not intersecting, then they will intersect in 0 points, means no point. So either in no point or 1 point. 2 distinct lines intersect either in no point or 1 point, but never more than 1 point. These lines are not going to take a curve like this. They are not going to take a curve and intersect in this 1 point and now second point. This cannot happen. Do you understand? And this is the statement of theorem 5.1. 2 distinct lines. Oh children, 2 distinct lines. 2 distinct lines can be in 2 forms. Either they are parallel or they are intersecting. Correct? Cannot have more than 1 point in common. This is common point. Point of intersection is common. जो point of intersection है, that is called common point. It is a point of line P1. It is also point of line P2. This is a point of line P, also point of line T. This, say suppose X, capital X, is a point of line L1. It is also point of line L2. So it's a common point. Common point is the point of intersection. Alright, let's see, we will prove it. Children, it's going to be difficult, but I want you to understand. I'll try my level best so that you can understand this statement. First, what is data? Okay. First, you should always draw the figure. So, two distinct lines, either they are going to be parallel or they are going to be intersecting. So, this is important. Alright? Please pay attention. Data. What is given? Two distinct lines. Two distinct lines. L and M. You can see the figure. L and M are two distinct lines. That's all. That is given. What you have to prove? To prove these lines cannot have more than one point in common. So I'll write that L and M. Which two lines? L and M cannot have more than 1 point in common. All right. Proof. You have to exploit this data. Data में हमारे पास क्या है? L and M are distinct lines. I'll write L and M are two distinct lines. Therefore, there exist two possibilities. There exist two possibilities. दो शक्यता है. Either they intersect or they do not intersect. One. L and M do not intersect. Do not intersect each other. And a second possibility, L and M intersect at point, let's say P. This is P. At point P. For point, capital letters are used. Okay. Now, if this is the situation, the two distinct lines are not intersecting, then how many points common they have? No point common. Alright. Okay. Now, where should I write? Okay. Please pay attention. There exist two possibilities. If, I'm talking about first, if first, i.e. L and M do not intersect each other, then what you can say? Then there is no point in common. There is no point in common. I'll call this as result number 1, which states that in this situation, no point is common. In this situation, no point is common. Okay? Please take a screenshot and copy this part, because second part is going to be a little bit lengthy. Alright? Okay? Let's see the second part then. Okay, just copy it. Done? Alright. I'll have to remove this. Okay? I'm removing this now. I'll keep only that second part now. Alright. Okay? Now see. Suppose L and M intersect at point P. Now, if that is 2, L and M intersect at point P. So how many points they intersect? Or how many points common they have? Only one P. But if any other point is there then? So let me suppose, let Q be other point the common point on L and M. Let P be other point, common point on line L and M. Now see children, P is on L, Q is also on L. So you can say L is equal to PQ. L is equal to, or you can say this way. See, P is already on L. Now Q is other point on both L and M. So P is a point on L, and here Q is also point on L. Both points are on line L. So you can say line PQ is equal to L. Call it result number 2. Alright? Chaliye. Now, P is on M and this Q is also on M. Therefore, you can say line PQ is equal to M. Are you getting me? यहां नहीं दिखा सकते हम, Q यहां भी है, यहां भी है. Q be a point on both L and M. So PQ on M, line PQ is equal to L and line PQ is equal to M. अब देखो ये तो सेम है, ये 3 by 2 and 3. It follows that L is equal to M. ये PQ लाइन तो सेम है, so L is equal to M. लेकिन L and M are distinct. डेटा में क्या दिया है? In data it is given L equal to M आ गया, which contradicts the data, therefore ये जो let किया हमने, let की जगह पे suppose लिख देते हैं, suppose, okay, therefore our supposition, all right, that Q is a point on L and M is wrong. That supposition is wrong. So what you can say? Therefore Q cannot be a point, Q cannot be a common point of L and M. ये नहीं हो सकता है. उसका मतलब P के अलावा कोई भी पॉइंट कॉमन नहीं है. i.e. P is the only common point of L and M. This is result number 4. Result 1 में क्या था? No point in common. Result 4 में क्या है? सिर्फ एक point common. So by 1 and 4, it follows that L and two distinct lines, L and M cannot have more than one point in common. Proved. All right. Please copy this also. Maybe you have found it tough, but go through this video again and again and try to understand. I hope you have understood. So we end up this session here. All right. Goodbye.